Okay, hi. Today we will present our research is study of microplastic contamination in soil, seawater, seagrass, and carbon sequestration in soil and seagrass at Park Hong Beach and Watanabe Dam Point. My name is Hakim Jantayotin.
And my name is Chipapat Chanakun.
And teacher name is Miss Bajari Chaipet from Princess Julapon Science High School, Trang, Thailand. Introduction: seagrass middle vital ecosystem for carbon sequestration and maintaining marine biodiversity, especially like dugong and sea turtle, rely on seagrass as a rich food source. Over the past 30 years ago, seagrass has been studied design since 1930. Seagrass has been described worldwide. Recent survey estimate that to 7% of seagrass is being lost each year. The prevalence of a football field every 30 minutes, according to 2023 survey by the Department of Marine and Coastal Resources. Seagrass in Tampuin are mostly in fair for moderate conditions with dominant species including Sorteta thalassica and Syringodium. However, Thai Sea faces the issue of microplastic accumulation in water and sediments, which may harm seagrass. Microplastic being non-biodegradable can absorb pollutants, leading to the accumulation of toxins in the food chain. Seagrass, with their unique adaptation for survival in marine environments, play a significant role in stabilizing the soil and storing carbon, making them more efficient for the forest as sequestering carbon that prevent carbon from being released into the atmosphere, helping combat global warming. Due to a design in the seagrass, in plant research and they compare microplastic level in the water, soil, and seagrass from the distant local at Park Hong Beach, a coast area with limited fishing and tourism, and the Motanoi Beach, a community area fishing activity. The study will examine the relationship between microplastic concentration and carbon storage in seagrass. Comparing the carbon sequestration in both areas, this research will serve a basis for raising awareness about plastic pollution in coastal area and inform statement for the conservation and management of seagrass ecosystem and microplastic contamination. Next is research question. Number of microplastic in soil and water around Park Hong Beach and Motanoi Beach, they are different. Number two is there are different in amount of microplastic size, shape, and color in the above ground, the underground part of the same and different type of seagrass. Three, the amount of microplastic size, shape, color is the same type of seagrass above ground and underground parts in Park Hong Beach and Motanoi Beach different. For seagrass above the ground and underground have an ability to store carbon is different. Number five, seagrass in Park Hong Beach, Motanoi Beach has the ability to the carbon storage different. Research hypothesis. Number one, microplastic in the soil and in the water around Park Hong Beach and Motanoi Beach, they are different. Number two, the amount of microplastic size, shape, and color in seagrass above the ground and underground, the same species and different species are different. The amount of microplastic size, shape, color in the same type of seagrass both in the soil and the underground parts of Park Hong Beach and Motanoi Beach is different. Number four, seagrass above the ground or underground and have the ability to store carbon different. Number five, seagrass in Park Hong Beach and Motanoi Beach has the ability to carbon capture is different. Research objective number one, to study the amount of microplastic in different soil and water. To study the amount of microplastic size, shape, and color of seagrass above the ground and the underground part. Number three, to compare the amount of microplastic size, shape, and color of seagrass the above ground parts and the underground part are different. Number four, to study amount of carbon storage of seagrass above the ground and underground. Number five, to compare the carbon capture capacity of the same type of seagrass, different species and different area. How to conduct the research? Study area. Figure 1 show the study area at the Park Hong Beach is A and Motanoi Beach is B. Data collection of the soil quality and water quality. Determine the soil sampling point by randomly dividing the sampling area into 5 points per study area. And next, study the property according to various index in the laboratory, including pH value, nitrogen, phosphorus, potassium, and metal value. Save data to the growth application is the land cover, water temperature, salinity, pH, and dissolved oxygen. Soil microplastic study. First, collect soil sample. Next, dye the soil and bed is at 60 Celsius degree for 24 hours. Next, sieve the soil on a safe size 5 mm and 1 mm. Next, put the soil operated into the WPO process and put it in the measuring, cleaning, and leave in the it for 24 hours. Next, after entering the WPO process, filter it with a 20 micrometer filter cloth and filter with a vacuum filter. Next, take a 24 micrometer filter cloth and TFC filter paper to the bag at 60 degrees Celsius for 3 hours. Next, take the sample to look with a stereo microscope and recording the result. Microplastic study in seagrass. Collect seagrass sample, cut into the small piece and digest it. After digesting completely, put in the measuring cylinder and let it rest for 24 hours. Next, after 24 hours, filter with a 20 micrometer filter cloth. After filtering with a 20 micrometer filter cloth, continue the filter with vacuum filter. Next, take a 20 micrometer filter cloth at GFC filter paper to bake at 60 degrees Celsius for 3 hours. And last, take the sample to look with a stereo microscope and recording the result. Microplastic study in water. First, collect water sample, put the water ultimately into the WPO process and put it in the measuring cylinder and leave for 24 hours. Next, after entering the WPO process, filter with 20 micrometer filter cloth and filter with a vacuum filter. Take a 20 micrometer filter cloth and GFC filter paper to bake at 60 degrees Celsius for 3 hours. And last, take the sample to look with a stereo microscope and recording to the result. Morphological preparation of seagrass. First, take a sample of seagrass cut into a small piece and dry to turbulent bowl for 1 minute. Next, put the sample into the side gas and take the sample with a microscope and take a picture. Carbon storage calculation. Carbon accumulated in seagrass MGC 2HA. Organic carbon content percent OC to dry weight of total seagrass in the area MGA. The seagrass area HA calculate the amount of accumulated carbon.
And next is experimental result with 3 parts. Part 1 is microplastic study result. This is water quality study. The study found similar pH and salinity levels at Pak Phong and Motonoi Beach, but the dissolved oxygen was higher at Pak Phong, as shown in the features. And next is study of the characteristics and color of microplastics in water. The microplastic study found more significant differences in levels between Pak Phong and Motonoi beaches. The highest concentration was at Motonoi Beach. Next is study of characteristics and color of microplastics in seagrass. The study found a significant difference in microplastic levels between seagrass at Pak Phong and Motonoi beaches. The highest concentration and largest microplastic were found in the above ground seagrass at Motonoi Beach. And this is study of the characteristics and colors of microplastics in soil. This is morphological study of seagrass, which you can see that in the left side, we have more space than the right side. Soil nutrient study as shown in the table. Study of carbon storage of seagrass. You can see that Cymodocea from Pak Phong have the most carbon storage, but Thalassia from Motonoi have the lowest carbon storage. This is the relationship of accumulated carbon with the amount of microplastics in the soil. The relationship of accumulated carbon with the amount of microplastics in seagrass. So you can see that if we have numbers of microplastic in high level, we will got carbon sequestration in low level. But in the other hand, if we have high carbon sequestration, we will have low numbers of microplastics. Conclusion and discussion. Microplastic level in water at Pak Phong and Motonoi beaches were similar due to their shared geographical features. However, soil microplastic concentrations differed significantly, with Motonoi Beach showing the highest levels, particularly around Thalassia seagrass. This is due to Thalassia longer leaves and filaments that trap more microplastics. Microplastic levels were higher in the above ground part of seagrasses than in the underground part, with Thalassia having higher concentrations than Cymodocea. Most microplastics were filamentous and black, likely from fishing nets. Regarding carbon sequestration, seagrasses stored more carbon in their below ground parts due to higher organic matter content. Higher microplastic levels in the soil were linked to lower carbon sequestration. Thalassia at Motonoi Beach, with the highest microplastic concentration, had the lowest carbon storage, while Cymodocea at Pak Phong Beach, with lower microplastic levels, had the highest carbon storage. This reflects Motonoi's community and fishing activities versus Pak Phong's enclosed low waste environment.
Okay, thank you.
Thank you.